Hello, you absolute legends. My name is Don Cavanaugh, and if you're into the barbell training and velocity-based training and you love units, you're going to love this video. I want to take units of formal vocabulary, such as newtons, joules, and watts, translate them into their fundamental units that'll become more digestible, and then which of those fundamental units is described by vocabulary we use in the gym, such as load, intensity, velocity, distance, things like that. So starting in a fundamental unit of force is the newton. Now Newton, in his fit of hubris, named after himself, and the units of a newton come down to F equals ma. Actually, that's not really the units. That's just the law right there. Let's actually put in the units of a newton right here. F is what we call the force, is what we call a newton with a capital N. Mass, let's just call that kilograms. And then acceleration is meters over second per second. For the case of what we use in the weight room, because we are doing all of our work against gravity, and gravity is an acceleration in this direction of meters per second, we don't really ever record gravity because it's constant. So load or intensity on the bar, this unit of kilograms we call load intensity. Weight on the bar. If you are interested in knowing the force, if you are interested in knowing the newtons that you have exerted on a bar, knowing just the load or intensity is enough. Because if you did two lifts, if you did two squats, one was 50 kilos, the other was 100 kilos, gravity is the same every day. So just knowing the newtons that you expressed, the proxy is only knowing the load or intensity. A joule. A joule was also humbly named it after himself. A joule is a force exerted over, a joule is newtons exerted over a distance. Well, newton is capital N over a distance that is multiplied by m. On the other side of the equation, now a newton is defined as this already, so that's got to be here. Kilograms, meters times second. Remember, that is our load on the bar. That is our acceleration due to gravity, which we don't really do much with in the gym. The meters up here. In this format of dimensional analysis, the units on this side match the units on this side. Note that what is circled in blue is what is written directly above as equivalent statements, and the only difference is that, and because it's the same on both sides of the equation. Discussion in joules. Again, the gravity we don't really talk about or use it in the gym because it's the same every day. It's the same every day all year. The load on the bar, kilograms. The distance that was moved here. So if you know the load, if you know the kilogram, or the load and intensity, and the distance in meters that the bar moved, and a lot of velocity trackers will tell this, you can calculate the joules that you must have done to move that weight such a distance. People don't really use this that much in the gym because when you're comparing a squat of week 1 to week 5, the range of motion of the squat is pretty much the same all the time because you do the same squat technique. The only difference is the load. I mean, that's going back up here. Where this is really helpful is, let's say maybe you're having an argument with your friend, and they say that you do more work during such lift as opposed to whatever work doing another lift. Two different lifts. Two different lifts would have, one has a higher load but a shorter range of motion. One of those lifts has a lower mode but a longer range of motion. Oh my God, how could you compare these? This could be one proxy of doing this, just multiplying these two numbers together. That value would be, the higher the value, the more joules right there. Last one is wattage. Wattage is a Newton over a distance and time, so a velocity. A watt, also humbly named after himself, is a Newton with a velocity attached to it. So my N, remember this letter up here represents all of this jazz. And we have said that the gym vocab for this is load on the bar. Because this is gravity, we don't really think about it. And then the velocity. What is circled in blue is meant to be identical on both sides of the equation, and also meant to guide your eyes that Newton, F equals ma, the load on the bar is a parameter in this idea of looking at velocity training. The velocity times the newtons is specifically watts. In the gym vocab, all you need to know is the load on the bar and the velocity of the bar. So the load and the velocity, meters per second. You can use only those two numbers as a proxy for calculating the wattage, because the effect of gravity is consistent every day, all the time. This was helpful for me in trying to determine how to calculate watts, how to figure out newtons, and also this kind of nebulous term here, joules, which is still kind of baffles me at times and confuses me. I hope this helps. Thank you so much.